Hey everyone, and welcome to a new series. Now, in this series, we are looking at Year 9 linear relationships. And I thought I'd open with this series by obviously, we are looking at a new topic, and a lot of the stuff from Year 9 linear relationships, it opens up with a lot of the things we learned in the Year 8 course. So, I'm going to do this video to bring you back to a concept that we've learnt about before, the idea of an intercept and what that means, and applying a new type of intercept, which helps us to sketch graphs a lot easier. So I'm going to give you guys an equation or a linear relationship, and we are going to look at an easier way for how we may want to sketch this graph. So in example 1, let's go straight into this. I have 2x plus 3y equals 6. Now, using what we already know about linear relationships, we could move everything to the other side except for the y and have our form y equals mx plus b. So we could change this into gradient form, gradient intercept form. But I want to just show you guys something that may help us do this in a slightly easier way when given a linear relationship that looks like this. Now, if I draw any line like this, so for example, one that we have here. Now, this isn't necessarily the graph for what I have here, but we learned before about a very special part of my graph. And this is the idea of a y-intercept. Now, this is that word we have in the title, the idea of an intercept. Now, some linear relationships, you can see with this one in particular, an intercept means it just passes through one of the axes. So whatever the y-intercept is of our linear relationship, that just tells us the y value that the graph passes through when it goes through the axis. But you can see this graph also passes through the x-axis at one point. And this is what we call the x-intercept. Now, we only learnt about the y-intercept in the last course, but here we can actually think of a lot of linear relationships as having both an x-intercept and a y-intercept. Now, let's think back to the idea of a y-intercept. There was a particular relationship between the x and the y when we got our y-intercept. So we talked about this idea of, well, if I were to trace this graph along as we go up, right? We're starting here, and at the bottom here, I have some negative value of x. So some value of x here. And as I pass along this line, my x is getting bigger, 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 bigger. And right at this exact point, this blue dot, which we call our y-intercept, my x value is 0. So I'm just going to write that down here just to remind you guys. So the y-intercept happens when x equals 0. So the x value, or the x coordinate at the y-intercept is 0. Now let's look at what happens in the x-intercept. And let's look at, well, if the y-intercept depends on something with x, let's see if the x-intercept depends on something to do with y. Now, let's say I started up here instead, and my y-intercept here is quite positive. And as I trace down my line, my y is getting smaller, 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 smaller. And once again, at this blue dot, my y is actually 0. So not only can I say I get a y-intercept when the x-coordinate is 0, but I also get an x-intercept when the y-coordinate is 0. And let's write that in here, when y equals 0. So these two realizations help us to dismantle a linear relationship like the one we have up here, and we can actually, just by finding the intercepts, we can get a pretty good rough sketch of the graph. Now remember, we're just sketching the graph. We don't need anything perfect. We just want to show some key points from our graph. Now I'm going to use these two ideas to find the x and the y-intercept of this linear relationship. And using that, I'm just going to draw a rough sketch of what this looks like. So let's start with what we're used to. Let's find our y-intercept. So our y-intercept occurs when x equals 0. So I'm going to substitute this value of x into here because the y-coordinate at that point when x equals 0 is going to be my intercept. So if I substitute that in, let's do this in another color, we get 2 times 0 plus 3y equals 6. Now, 2 times 0 gives me 0. So this term here is going to get killed. So I have 3 lots of y equals 6. And I can just solve this equation in the same way I've been solving equations this whole time. When we get here, I can just solve this by inspection. I can say, well, if I know my times tables, I know what number multiplies by 3 to give me 6. That number is 2. So this number here is my y-intercept. Now let's make a note of that here. This is my y-intercept. Now, that word y-intercept, that is the same thing as the y-coordinate when x equals 0. Those two phrases are sort of synonymous. So you can see here, the y-intercept is the y-coordinate, how high the graph is in the vertical direction when x equals 0 at my point x equals 0. Because 0 is this mid point here where these two intersect. So right at this point in the middle, that's the point 0, 0. 0 in the x and 0 in the y. So we found my y-intercept. Now let's find the x-intercept here. So my x-intercept I get when y equals 0. Now, I want to substitute that value of 0 into my y here. And when I do that, 3 times 0 gives me 0. So that is going to kill that entire term. But let's just show all the working here. So I get, what was it? 2x plus 3 times 0 equals 6. And once again, this is going to get killed off. 3 times 0 gives me 0. And 2x then equals 6. And then therefore now I'm looking for a value that multiplies by 2 to give me 6. So my x is going to be 3. And now that I have these two terms, an x-intercept and a y-intercept, x-intercept, now I can draw the graph to a pretty good level of accuracy. So if I take these two bits of information and I draw the graph on my right over here, I have my y-axis, I have my x-axis. My y-intercept, how far up the vertical direction, that's going to be 2. And my x-intercept, where it passes in the x, is going to be, that is going to be 3. So I'm just drawing in what I've already found. I found a y-intercept, I found an x-intercept. Now, what's the line going to do? Well, it's just going to join these points together. So let's draw that in purple. My line is going to look something like this. Passing through both y equals 2, or the y coordinate of 2, and the x coordinate of 3. And these points, actually, we can label those or my y is going to be 0 on the x-axis, 2 on the y-axis, and my x-intercept is going to be 3 on the x-axis, 0 on the y-axis. So you can see these points here satisfy these definitions we looked at. So for example, here I wrote x-intercept when y equals 0, and here you can see y equals 0. It's my x-intercept. My x value is 3 when y is 0. And up here I said y-intercept I get when x equals 0. Here is my x value of 0. And the y coordinate alongside that is going to be my intercept. Now let's look at maybe one more question. And that's going to be, I'll go through this one a little bit quicker because hopefully by now you guys are getting the idea. But here I can see my graph is in gradient intercept form. So I could draw that too and labeling in the gradient, but I can also just as easily use my x and y intercepts to find what that value is going to be. Now, because this is in gradient intercept form, I already know what my y-intercept is going to be because my linear relationships, just to recap, are in the form of y equals mx plus b. Some people say c, where this is my gradient and this is my y-intercept. But let's just check this using the same thing that we did, because if we do it in the same way, our strategy of letting x equals 0 to get a y-intercept, that should obey just this idea of reading it off like we've done here. We should get the same answer if it is indeed correct. So let's do that. Let's find the y-intercept first. So we get my y-intercept when x equals 0. So I'm going to substitute 0 into here. So my y equals 2 times 0 minus 6. 2 times 0 gives me, whoops, let's do it in another color. 2 times 0 gives me 0. So y equals minus 6, or the y-intercept equals minus 6. And that just checks out with this thing here. Because this is saying y equals mx, with the m being the gradient of 2, plus minus 6. So my y-intercept, if I just read it off the equation, is also going to give me minus 6. So I've done it correctly. Now let's just try to find the x-intercept here, which once again we can find by setting y to equal 0. So doing that, instead now, I'm putting 0 over here in my equation. So I get, let's do this in another color, I get 0 equals 2x minus 6. And now I want to solve this equation. So 2x, if I subtract 6 from that, I get 0. So solving the equation, I can just add 6 to both sides to see what 2x would be. So I get 6 equals 2 times x. Now we just want to find what number multiplies by 2 to give me 6, and that number is going to be 3. So I have found now my y-intercept. Oops. I found my y-intercept, and I found my x-intercept. So now I can just draw my linear relationship over here on the right-hand side. So I have my y-axis, I have my x-axis. Well, my y is going to be negative 6. So that's going to be like down here somewhere, negative 6. And my x is going to be 3. And if I join those two up, I get a nice, it looks terrible, sorry. I get a nice linear relationship. And just for a little bonus thing at the end here, if you want to stick around, what this is telling me is I've sketched my graph, but let's just double check if what I've shown here kind of fits in, at least we can generally see it, fits in with this idea of a gradient of 2. So what the gradient means, as a recap, that is the idea of how much my y changes when x changes by 1. So if I move one number up in the x, how much is my y changing? Now here this is saying that this is 2. So when x goes up by 1, y goes up by 2. Now let's just check if I've done this correctly. So if my x goes up by 1 here, my y goes up by 2. So my y is going to hit at -4 here, and this is at the point 1. And if I go up by 1 in the x again, I should go up 2 in the y. So I've gone from 0 to 1, from 1 to 2 in the x, and I've gone in the y from -6 to -4 to -2. And if I go up by 1 again in the x, I go up by 2 in the y. So this makes sense, right? Because I've hit 0. I've hit the point where y equals 0, which is always where my x-intercept is going to lie. So as I've tracked this up, going, all right, for one movement in x, I have 2 in the y. For 1 in x, I have 2 in y. For 1 in x, I have 2 in y. I end up getting +3 as my x-intercept, and I have -6 as my y-intercept. So this checks out. I can sketch my graphs using both methods now, using the gradient intercept form, as well as finding both the x and y intercepts and then sketching from there. But this method, for me at least, and especially when we get to some harder looking linear relationships, kind of like this one that isn't in gradient intercept form, finding the x and y is a far easier way to deal with these types of questions when sketching is involved. But thank you so much for watching, guys, and I'll see you in the next video.